section, which is 7.4. And we'll cover the last section, 7.5, on Monday, and that will be the last new stuff, finally. And so before we get started with 7.4, are there any questions or major issues with any of the things that we've talked about so far? No one really hung back yesterday to chat or to do extra problems. So in my mind, I'm assuming it's all good, but that probably necessarily isn't the case. So you guys got to let me know. So any major issues right now?
Nope.
Okay. Okay, so section 7.4, we are going to be talking about the properties of logs. And so I mentioned the other day when, just like every topic that we've covered, fractions, equations, things like that, we can add, subtract, multiply, and divide logs, okay, just like we have been. And so we're going to look at those properties. And then when we're finished looking at the properties, we're going to talk about some real life applications that actually use logs and exponential functions in real life, like some types of sciences, chemistry, things like that. So we'll go ahead and get started. And there's only a little bit of notes, really. Most of the time that we're going to be spending today is going to be actually working on examples. So let me get my whiteboard up here, and then we will get to it. So, all right, let's see. Make sure everybody can see everything. Okay, so you guys know by now, stop me along the way if we need something. So this is going to be 7.4, properties. This is a PRO. Properties and applications of logs. And so whenever we talk about the properties of logarithms, there are three main properties that we're going to have to use. And if we think way back, do you guys remember this from several weeks, several months even?
Oh, okay. Yeah, multiplication, addition, division, subtraction.
Exactly. And what did we
use?
They
were like interchangeably.
Yes. Okay, and we used these when we talked about exponents, right? And we said that if we were actually multiplying exponents, we were actually adding them. And if we were dividing exponents, we were actually subtracting them. Okay, well, here's the cool thing about this. When we talk about logs, they're kind of like exponents. And so believe it or not, we're going to use this maths business again, okay? And so here are the properties that we're going to be looking at. There's just three of them, okay? And you're going to be like, oh, this isn't so bad. So here's the first one. If we have log base A, and then we're going to have a set of parentheses, and we're going to have two things. Right now, we're just going to call them x times y. If they're being multiplied together, okay, if we have numbers, because remember, when we have two things written out, there's actually multiplication out between the two. So if we have the log of A, log base A of something times something else, we're going to be able to rewrite that as, and actually, I'm going to erase maths for just a moment because I'm not going to have enough space. We're going to be able to rewrite this multiplication, let me get myself back together here, as log base A of x, which is the first thing that's being multiplied. And instead of multiplying, we're picking this thing apart by turning it into addition. And then we're going to write log base A of y. And that's it. So when we have two things that are being multiplied together inside a set of parentheses, the multiplication turns into addition, and we write them separately.
So you're just breaking them up into two separate logs to like add together.
That's exactly what I'm doing, yes. Okay, so that's just the first property. And as we progress with these problems, obviously we're going to use these properties, but we have to see them first, okay? All right, now the second property is going to be with division. Okay, so let me get my marker back out here. And here we go. So property number 2 is if we have log base A of x and it's being divided by y, and that's in a set of parentheses. Well, when we're dividing exponents, what are we really doing with them?
Subtracting.
Mm-hmm. And so here's what's going to happen. This is going to become log base A of x minus log base A of y. And that's it. We're literally just pulling them apart. We're turning this division into subtraction just like we did when we were dealing with exponents. That's pretty cool, right?
Mm-hmm.
Okay. All right. Thank you for your enthusiasm. Okay. So the last one that we have to look at is going to be, we've not talked about this one. I don't have a cool special name for it, but here's what it says. If we have log base A of something and we're raising it to a power. Okay, so think about this. Way back when we had exponents, don't write this in red, but just think about it. If we had power to a power, what did we do with these two pieces?
We added them.
We didn't add them.
Well, multiplied.
We multiplied them. So what's going to happen is we're going to turn this into, we're going to bring this little r out front and we're going to multiply it out front by the log. And that's it. Those are our three properties. So do you have to know these? Absolutely. So when we're multiplying, we're going to pull them apart and we're going to actually add the logs. If we're dividing, we're going to pull them apart and we're actually going to subtract the logs. If we're raising something to a power, we're going to bring it out front and we're going to turn it into multiplication. Has anybody ever done this before?
The first two, definitely not the last.
Okay. All right, so if you haven't already written these down, do me a favor real quick, take a picture or something, because we're going to move on to do examples, and we're going to have to refer back to these three. Okay, but I can't rewrite them every time because I don't have enough space. And also keep in mind down here, keep in mind the MADS business, okay, because that's not going anywhere. We're still going to use that. All right, now we're going to use these properties of logs to do two things. Okay, we're either going to expand them, which means to make them bigger, like we did over here, or we're going to condense them, which means to make them smaller, like we started out with. That's the idea. Okay, and we're going to start off easy. We're going to work our way up, all right? Because I'm telling you right now, sometimes Hawks just throws you in and says, hope you can swim. Okay, but you know, I don't like to do that. So let's just start with number one. Actually, hold on, don't write number one yet. So what we're going to do first is we're going to talk about how to expand these things. And when we say the word expand, we mean take one and turn it into many. Okay, that's what we're trying to do here. We're going to be given one log and we want to turn it into many logs. Okay, so here we go. Number one, if I give you log base 2 of 6y, so that's the problem. Okay, and our goal, so that's our one, and our goal is to turn this into many. And so if we look at this, what's happening inside these parentheses?
Multiplication.
Multiplication. And so since multiplication is happening, when I expand this or when I pull this apart, what am I going to turn that multiplication into?
Two addition.
Yeah. And so this is going to become log base 2. The first number is 6 plus sign, and then log base 2 of y. And that's it. What do you guys think?
It seems fairly simple.
Okay. All right, so we're just going to keep going, all right, until
I think it's too simple.
It's not, though. Like you guys keep saying, I'm trying to trick you. I'm not, right? Those logs that we talked about yesterday, you said this was too easy. Well, it didn't get any harder, right? It was the same thing over and over and over. All right, so then let's take a look at the second one. Okay, we'll just keep trucking along here. So what if we have log base 3, and then in parentheses, I have x squared, y squared. So that's the problem, log base 3 of x squared, y squared. So the first thing we're going to do is look inside these parentheses and say, okay, what is happening inside these parentheses? Multiplication, right? But we also have these exponents. So the first thing that's happening is the multiplication. So let's deal with that. If it starts out multiplication, I'm going to turn it into addition. Okay, so we're gonna have this. We're gonna have log base 3 of x squared plus log base 3 of y squared. Okay, that's me taking care of the multiplication. Now, we have powers, right? We have these little guys. And when we have a power and it's being raised up, we have to turn it into multiplication. So this little guy is going to come out front, and this little guy is going to come out front. And we're going to rewrite this whole entire thing as 2 log base 3 of x plus 2 log base 3 of y. And this is my final answer. So take a second, okay? Look at these two. See what you think, see what you know, what kind of questions you have or whatever. And we're going to keep moving on. So if you need something, you got to let me know. Anything on 1 and 2?
Could you like put a 2 and then parentheses and then logs and then
like this?
Yeah, and then get rid of that too?
You could. The problem,
no.
the issue with that is when you're going to type your answer into Hawks, they're going to give you this box, and then they're going to have the word log. and they're going to have another box, and then they're going to have another box like this. And you're going to be putting like your 2 here and your 3 here and like your X here. And there's not going to be parentheses.
Okay.
But if you're handwriting them, you absolutely can put those parentheses. It will not affect your final answer.
Okay. I
Okay?
meant more like 1, 2, and then put the whole equation into parentheses. Does that make sense? Or is that not
Oh,
right?
yeah. So you mean, and actually we're going to do one like that. So you're talking like this. So parenthesis, and then base 3 of y. Yeah, that's fine.
Yeah. Okay.
Okay. All right. Any other questions on 1 or 2 before we move on? Okay. So number 3. So what if I have log base 4 of 16x to the 8? And so the first thing I do is I look inside my parentheses and I say, okay, what's happening? Multiplication. And when I see the multiplication happening, that tells me I have to turn it into addition. So that's the first thing I'm going to do. So this is going to become log base 4 of 16 plus log base 4 of x to the 8th. Okay. Now, this is a special type of problem, I guess. Remember, okay, this is a side note. If all I had was log base 4 of 16, typically we would put equals y, we would draw these arrows, we would have 4 to the y, 16, we would get y is equal to 2. So there will be some problems where you're presented with half of it or a piece of it that actually can be simplified to a total number instead of just a log. And we have to try to start recognizing those. And so the trick behind that is if you have just 2 numbers, sometimes this whole entire bit can turn into just a single number like this guy down here as a number 2. And so what we're going to look for is we're going to look at our base and we're going to look at the big number. We're going to ask ourselves, can this base somehow turn into this big number? The answer to that is yes, right? 4 squared is what gives me 16. We just proved it over here. And so sometimes while we are expanding, instead of leaving it as log base 4 of 16, we're just going to rewrite it as the number 2. And then this is all taken care of because over here's the proof. Because I know that, log base 4 of 16 is 2. Okay, so let me pause. You think about that. We just had 2 numbers. We're trying to teach ourselves to recognize when the log is actually going to give me a constant. So what are your thoughts on that first piece?
Will it tell us like when we have to do that on a worksheet or a test, or will we just have to know?
Okay, so it's just going to say, expand or condense, and simplify completely is probably what it's going to say. And so you're going to just have to try to start recognizing this stuff on our own, which is why I'm trying to show you now. So it's not going to come out and say, hey guys, this little dude's going to come to a constant. It's just going to say, hey, I need you to go ahead and just expand this. Okay.
Okay.
So if you look over here, and here's another little thing. If we're just looking at this guy, this is a number, but this is not a number. So that's not going to happen here. So we're just going to expand like normal. We're not going to have to worry about trying to turn it into a nice little number. So we're going to put our plus sign. And over on this one, we have this power. And where do the powers have to come? Right out front. And so this is going to turn into 8 log base 4 of x. And this guy's just a 2, and this guy's as simplified as we can. And so this is my total and complete and final answer. Now, of course, this takes practice, okay? And so we're going to do more. And then, of course, you have your worksheet and you have your hogs and stuff. So hopefully you'll start recognizing some of these numbers. So this is a side note, not even related to this, this particular problem. But what if we had like log base 6 of 36? Well,
Oh, then it would just be 6.
not 6, because 6 to what gives me 36?
2.
It would still be 2, yeah. So what if I had like log base 7 of 49?
2.
2. So the ones that we're going to see most commonly are going to be the perfect squares. So when you see just numbers, ask yourself, hey, does this number somehow turn into this number? And if the answer is yes, then it's going to become whatever that is. Now, what if this would have been a 48 instead? We would say, well, does 7 turn into 48? No. And so it would have to stay log base 7 of 48. So it just takes practice, okay? It just takes exposure to what I'm trying to tell you. All right, so let's go back to 3, though. Any other questions on this one before we move on to 4? Because now we're going to start looking at some division problems because we haven't done one of those yet. Okie dokes. So let's take a look at 4. All right, so we will have log base 3 of 7 over x. Okay, and we're still trying to expand it. And so we look inside the parentheses to see what's going on, and we see this division. And so we know that when division is happening, we're going to turn it into what type of a problem?
Subtraction?
Yeah, subtraction. And so since 7 is on top, it's going to come first. So we're going to write log base 3 of 7 minus log base 3 of x. Done. That's it.
With the subtraction, does it kind of work like the addition that if you could, if there was a perfect square, you would take it?
Yeah. So if this was a 9, let's just quickly make it, then this will become 2. Absolutely right.
So we just have to recognize those perfect logs.
Yes. Okay. And like I said, by us doing practice and by you doing practice, you will be able to recognize those much better. And like I said, the most common one that we're going to see is if it's a perfect square. We will see a couple of cubes here and there, but for the most part, it's going to be the perfect squares. Okay. All right, so what do we think about 4? That was pretty straightforward, right? It was division, we turned to subtraction, bam, we don't have any other powers, we're done. All right, let's take a look at 5. Okay, so we'll have log base 2 of 6x over y. And so the main thing that's happening here is, of course, division. And so somewhere along the line, I'm going to have to turn this into a subtraction problem. However, if I look in the top, isn't there also multiplication happening? Somebody say yeah.
So then you'd have to make that part addition.
Yeah. And so what happens is the order that we make our answer follows the order that the problem is presented to us. So the first number we see is 6, then we see multiplication, then we see x, then we see division, then we see y. So what's going to happen with this guy is we're going to start out log base 2 of 6 because that's the first thing that we see. The next thing that we see is multiplication, so we're going to have to add. Then we see this x, so log base 2 of x. Then we see the division, which will become a subtraction problem, and then we see y. So log base 2 of y. That's it. Because right here is my addition, which was my multiplication, and then this guy is the only thing on the bottom of the fraction, which is my division. And so I have something plus something minus something. And that's going to turn into my, that's going to give me what I started with over here. So this guy is my total answer. So what do we think about that?
It's not bad. You
It's
just
not
have to
bad.
recognize when you have a second piece you have to work with.
Exactly. And so I'm just telling you now, these types of problems right here are going to be super rare. I'm showing you this. Hawks didn't even show you how to do one with just one term. They threw you into like 6 terms, okay? Obviously, I don't like to do that, and I'm not going to do that. So we're not going to see a lot of problems that are this straightforward. Most of the problems that we see are going to have at least 2 terms. So we have to make sure that this is making sense to us. So let's do, okay, I'm going to get a new page because I'm going to run out of space because I write a little too big with this thing. All right, so we have log base 3, and on the top, we're going to have 2x to the 3rd, and that's going to be divided by y to the 4th. So you can already see that we've kicked up several notches because now we have 2 things up top, and we have exponents, and so a lot's going on. All right, so the order that this problem is presented to us, the 2 comes first, then the multiplication, then the x, then the division, then the y. So this is first, this is second, this is third, this is fourth, and this is fifth. So as we progress to write our answer, we're going to start out, we're going to say, actually, I'm just going to write it below. No, I can squeeze it on here. We're going to have log base 3. The first thing that we come across is just this 2. So log base 3 of 2, fine. The next thing that we see is this multiplication, which means plus sign. Then we see x to the 3rd. So we'll have log base 3 of x to the 3rd. Then we see this division bar, which means subtract, and then we see y to the 4th. So log base 3 of y to the 4th. Now, we have expanded it. However, once we rewrite it, we have to go through each little section and ask ourselves, are we done? So looking at this little guy only, is the number 3 going to be nicely raised and give me a 2 at all?
No.
No, so this will stay log base 3 of 2. Okay, next is my plus sign. Great. I look at just this guy in the middle. Can I somehow simplify this guy in any way?
Well, the cubed.
Yeah. Where does it have to go?
To the front.
Exactly. So we'll have 3 log base 3 of x. And then he's taken care of. Check. And then a subtraction sign. And then the same thing back here. What's going on with this 4? It's a power, so where does it have to go?
Front.
Okay, so log base 3 of y. And there we have it. Ta-da! Done. So see, even though this looks really big and kind of bad, I almost want to say that we kind of already knew all the rules. It's just a matter of doing them a little bit differently. So we've done what, 6 examples? What do you think so far? Any questions? Any problems?
I was writing down my answer and I was forgetting to write my base.
Oh, yeah, that's super important. Okay, got to make sure that base stays. All right, so I have a few more, and what's going to start happening now is we're going to kick it up several notches, all right? And don't let that scare you. It's just going to look different. The rules will still be the same. The presentation is going to be different. And so I have to make sure that you're like, oh, okay. All right, so I have a few more, and then we're going to kind of go in reverse, and instead of making them bigger, we're going to be given something that is big that looks like this, and we're going to turn it into something small. So this process works forward and backward. So let's take a look at the next one, and let's see if we can, kind of decipher what this one's saying. So here we go. So we have log, and then in parentheses, I have 1.2 times, okay, you know what, let me put this, this is a little multiplication sign, not an x, 10 to the 8th, and all of that is over x to the negative 4. Okay, so this is one of your examples that were on the, that was in the notes from Hawks. So you're definitely going to see this again. Okay, so I have to make sure, excuse me, that we know how to tackle this.
Can
Right,
you
so
reread the top, that 1.2?
Can I reread it? Is that what you said?
Yeah.
Yeah, it's just 1.2 times 10 to the 8th. So maybe
Okay, that's where I was getting confused because I just put x.
yeah, and see, okay, is that better? My multiplication dot?
Yeah,
My
that's
line
better.
really then on me. What happened? Ugh, come on now. Okay, so that's the multiplication. Sorry, I'm having an issue this morning already. What's going on? There we go. All right, multiplication dot. Okay, so here's what we're gonna do. All right, we are going, and notice real quick, I didn't even point this out. Notice that there's no visible base yet. Do we see that? Remember what happened yesterday? We said if there is no visible base, what's our base actually?
10.
Yeah. Okay, so just checking. Okay, so here we go. So the first thing that we come across is this number 1.2. So that's the first thing. And then we come across the multiplication dot, and then we come across 10 to the 8th, and then we come across the division bar, and then we come across this guy. So we've got 1, 2, 3, 4, 5 things again. Okay, so we're going to start out, and we're going to write log of 1.2, and that's taking care of this guy. Now, since I see this multiplication dot, what do I have to put?
Plus.
Plus, and then I have 10 to the 8th. So I will put log and 10 to the 8th. Okay, so that's taking care of this, and that's taking care of that. And then I come across the division bar. And when I see the division bar, that tells me that I have to insert what type of a symbol?
Subtraction.
Subtraction, perfect. And then down here in the bottom, I see x to the negative 4. So I will just write log x to the negative 4. Okay, and so now I've pulled it apart at least, but as you already know, because we just did it, we have to make sure that every single piece is simplified. So I'm just looking at this piece first, log of 1.2. I don't know how to even deal with the decimal, so I have to just leave it. So my answer is going to start out log of 1.2, then my plus sign, and then I'm going to say, okay, well, now I'm looking at this, log of 10 to the 8th. Now, I want to pause you for just 1 second. Okay, remember how just a minute ago you said that technically there's a little base 10 right here? So I'm going to stick this 10 in here real quick. So watch. Now, remember how like 5 minutes ago we said when we just have numbers inside, we got to check. So we need to know, does the number 10 somehow become 10 if I raise it to a power? Yeah. It's 10 to the 1st. Okay, so what's going to happen is, somewhere in our notes yesterday, there was a statement, and I'm just going to erase this in just a second, but it said if we had log base x of x, that was equal to 1. Does anybody remember that?
Yeah.
And the reasoning behind that was because x to the 1st equals x. Well, if we look right here, let me get a different color. If we look right here, we have log base 10 of 10, which we already said was going to be 1. So what's about to happen here in this middle term is when it becomes a 1, the only thing that's going to be left is this 8. And it's not just 1 to the 8th, it's actually just 8, because we've brought this 8 out front because it's a power. And what is the number 8 times the number 1?
8.
So this middle term, after all of that mess, is just going to be the number 8. Okay, so that's going to be another one of the types of problems where we're going to have to try to recognize, excuse me, recognize that it is actually a perfect log, so to speak, and it's going to give me a whole number. All right, now we're going to keep going. And when we see this power out front, or in the back, excuse me, where does it have to come?
To the front,
And what happens when we have a negative and we multiply it by another negative?
it's a positive.
Plus. And so the force come down, and that leaves me with log of x. And this is my total and complete and final answer.
Can I ask a question?
Absolutely.
So for the middle one where it just crossed out and became just 8, what if on the test we wrote like log 10 to the 10 and just left it that way?
I mean, so here's the thing. Remember, you're typing this into Hawks, okay? And I'm almost positive, because I got these questions from the homework. The way that
Mhm.
Hawks is laid out, in little Hawks's mind, it knows this should be a whole number, right? And so what's
Okay.
going to happen is they're going to give you this box, log of something, plus they're only going to give you one more box, and then they're going to have plus box, the word log, another box. If I'm not mistaken, you're not going to be able to type this into that box. They're going to make you have the whole number. So let's pretend you're on the test and you're like, man, I just don't know what to put here. Just make sure on your paper, you've got this written so that when I go back and I check your paper versus your test, I can look and say, oh, she had it. She just forgot how to change it. Full credit. Okay. Or
Okay,
whatever
so-
the case might be.
So Hawks, it'll probably do that thing where it's like, this character is not needed. Blah, blah, blah.
Exactly. And you're not,
Okay.
it's not going to let you type in the letter, and you're going to get frustrated. And that's when I say, hey, listen, just make sure on your paper, you're very clear. You're like, hey, this, Amanda, this is what I want you to check, or whatever. Okay. Just make it very clear to me so that I can say, oh, she got this far. She forgot about the 8. It's not a big deal. Next problem. Okay. That's one of the reasons why it takes me so long to grade your guys' tests, because, you know, I've got 50 of you and I go through and I grade each one by hand. So it takes a while. Okay. So
I have a question.
yeah, go ahead.
So we if this was log of 100, it would end up being 16. So we have to multiply.
Okay. So
Right.
hold on. So let me back up. So you're talking about this middle guy, right?
Yeah.
So if it said log of 100 like this,
Yeah.
and then it had
The 8.
to the 8th. Okay, so not quite. Okay, so hold on.
Okay.
Well, yeah, I'm sorry. You're actually right. I don't mean it like you're actually right. I mean, you are right. So this 8's going to come down just like you said. And then you're going to say, oh, 10 to the what gives me 100. And you're going to have 8 times 2. And so, yes, that would become a 16. You're absolutely correct.
Okay, yeah, just making sure.
Okay,
Thank you.
you're welcome. All right, anything else on number 7 before we take a look at number 8? All right, let's do it. Okay, so now this one is going to be log base 4, and then in parentheses we're going to have the number 64, and then we're going to have x, and then we're going to have the cube root of y. So I'm going to leave a little bit of space because I want you to understand that it's not x to the 3rd, okay? Because some of us read this, we think the 3 is a little too close to the x. So here's the problem, okay? And we know, okay, that between each of these, there's a multiplication happening, all right? So I'll just stick those little dots in there. Okay, so here we go. The first thing that we see is 64, and then we see this multiplication dot, and then we see this x, and then we see this multiplication dot, and then we see this big old thing, okay? And so we have to go through and we have to pull it apart, and then we'll go through and simplify if we can. And so I'm just gonna write downward so I don't run out of space. And so we'll start off with log base 4, and the first number that we see is 64. So we're gonna have log base 4 of 64. Based on this multiplication dot, what symbol's coming next? If I'm multiplying, I'm really, adding. And then I see my x, so log base 4 of x. And then because of this multiplication dot, I need to insert a plus.
Plus.
And then I write my base again, log base 4. And then I'm going to have the cube root of y. Okay, the cube root of y. Okay. Wait a second, hold on. I don't know why I put that parenthesis there. And I wrote this guy really far away. I didn't mean to do that. I was looking at something else. Okay. And so now I'm going to have to go through and I'm going to have to look at this piece first, and I'm going to look at this piece, and then I'm going to look at this piece. Okay. And so now remember, oh, hey, look, just numbers.
Oh,
My
they're
question-
perfect. It's a perfect cube.
It is. And so I'm going to ask myself, hey, look, these are just numbers. Is there any way that this number 4 is going to magically, turn into 64 if I raise it? And yes, it's going to just be 3. And so all of this stuff is taken care of, and I'm just left with the 3. Perfect. All right, plus sign. Okay, now moving on, I have log base 4 of x. Anything else happening here at all?
No.
Nope. And so this is just going to stay, whoops, whoa, log base 4 of x. Okay, plus sign. Now, we haven't seen a radical in the logs yet. So we got to back up for just a sec. Okay. Remember how several days ago we had said that if we have x to the 1/2, that is actually a radical. And we said that it works both ways, that if we have the square root of x, we can turn it into x to the 1/2. We talked about this yesterday and a couple of days before that.
Oh,
So
so we
if
can
I'm,
turn the y into a y with the little fraction as its exponent.
yes, and what's that fraction going to be?
1/3.
Yes, so this little guy is actually y to the 1/3. Perfect. Now, technically, this is an exponent. And when we have an exponent, where does it have to go?
To the front.
Yeah, so this is going to be 1/3 log base 4 of y. Done. So you see, I can tell that in your voices when you ask your questions, you're making these connections. It just may be something that you've never actually quite understood before. Because I know somewhere along the line in high school, from what I gather, it seems like you guys have at least touched on this, but didn't quite get it. Well, hopefully now that's not the case. All right, so what do we think about 8? Questions, problems on 8. I have 2 more that I want to do, and then we're going to switch directions, and we're going to take many logs, and we're going to make 1, okay? And these 2 are from the notes, just in case, because whenever you go into Hawks to Work, you're going to see these again, all right? So here we go. The next one is going to be log base A, and we're going to have the cube root, and this is a big cube root, and on the top, I have xy squared, and on the bottom, I have z to the 4th. Now look at this monstrosity. This is big, right? All right, so, well, as we're trucking along from left to right, the first thing that we come across is this cube root. And the previous problem, what did we do with that cube root? What did we turn it into?
1/3.
1/3.
Yeah, and we made it into an exponent. So guess what? We can still do that. So we're going to have log base A, and we're going to have x, y squared on top, z4 on bottom. And instead of taking the cube root of it, I'm going to raise it to the 1/3.
So does that go before every part?
Yeah, well, yes, but to save us some work, watch what's about to happen. So as we go forward, I'm going to X out the problem or X out the piece before because we don't want to look back. Okay, so this guy, gone. We don't want to look back. So here we are. And so now that we have this exponent and there's a bunch of stuff inside, where can I put this exponent to just get it out of my way?
To the front.
Yeah, so we'll have 1/3, and then in parentheses, well, not parentheses yet, I'm sorry. We'll have log base A, and then we're still going to have our xy squared, and we'll still have our z4. Okay, and so now my 1/3 is taken care of, so to speak. So it's just hanging out. And so now we're trucking along. We see 1/3, we see log. What's happening inside here? Multiplication and then division, right? And so someone said it. I'm going to have to turn it into addition and also into
Subtraction.
Yeah, so watch. So we'll start off with our 1/3. It's going to stay the same. And now I'm going to put a parenthesis. I think, Sophie, you asked me this question about 5 or so minutes ago. Since 1/3 is going to have to hit every single one of these, let's just put it out front with a parenthesis. And so we're going to say, all right, for the time being, 1/3 is taken care of. It's just right there. So we'll have log base A. The first thing we come across inside is x. Then we come across the multiplication dot, which is a plus sign, right? And then we say, oh, hey, look, here's y squared. Now, I'm going to teach you how to kind of skip some steps. If y squared, if we were to write it down, it would still be squared. But what do we know has to happen to this 2?
The 2 has to go to the front.
So let's do that first, okay? Why not? So let's put the 2, and then let's write log, and then we'll have base A of y. And then we'll have a subtraction sign because now we're dividing. And when we have this 4, what do we know is eventually going to have to happen to it?
Has to go to the front.
Okay, so why not do that next? And then we're going to have log, I'm going to space A of z. Done. So we took something that looked terrible and we did it in what, 2.5-ish steps?
Mm-hmm.
Yeah. So my final answer is going to be 1/3, and then in parentheses, we're going to have times log base A of x plus 2 log base A of y minus 4 log base A of z. Done. All right, what do we think? That's not so bad.
Mm-mm.
All right, now I have one more, okay? And this one is going to contain the ln, which we haven't seen today, okay? But you're going to notice that it works the same way. So here's the problem, okay? We're going to have the ln of x to the 8th. And then beside of it, we're going to have the square root of p to the 9th, q to the 3rd, like that. And then over that, or under it rather, man, we're going to have e to the 8th. Now this is a big problem, isn't it?
Mm-hmm.
Yeah. Okay, so the first thing that we come, and hold on a second, I gotta fix something. This ln is not on the top nor it's on the bottom, it's just beside. Okay, my pen just got a little out of control of me. So here's what we have. All right, so the first thing that we should probably tackle is this radical. Because if I didn't have the radical, it might not be so bad. So over here on the side, okay, we're just going to pause for a moment. What we really have is the square root of p to the 9th times the square root of q to the 3rd, really. And we know that when we do the square root, there's a 2 out here. Okay, we don't have to write it because we say it. Now, if all we had was the square root of x, we would know that this turns into x to the 1/2. And so we mentioned yesterday, whatever's out front goes on the bottom, and whatever's on the inside goes on the top. And then the radical's gone, and we have a fraction. So if we have the square root of p to the 9th, that's really p to what?
PQ.
Mm,
9. Oh, that's right.
how about p to the 9/2?
Oh, because you turned it into a fraction.
Yeah, because I don't want radicals. Okay, I don't really want radicals in my answer, and I don't really want them in my problem because they're messy. And so if I have the square root of q to the 3rd, that's really q to the
3/2.
Yeah. And so what's going to happen is, before I go any further, I'm just going to backtrack for just a sec, and I'm going to get, and I'm taking this radical out because I'm going to run out of space. You guys can write it if you want. Oops, hold on. I hit the wrong button. Oh my gosh. Okay. And I'm just going to squeeze in here over 2, over 2.
What if those are ever divisible?
Then you would just divide. And let's say if this was 9 divided by 3, then that whole thing would just become a big old fat 3 instead of a fraction.
Okay.
Okay.
Sure.
Okay, so let me get rid of all this because remember, we're not looking back. Okay, we're only moving forward. And so now this looks a little bit better. I mean, it's still not ideal, but it looks a little bit better. And so the first thing that I come across is this x to the 8th, and then a multiplication dot, and then this guy, this p guy, and then a multiplication dot, and then the q guy, and then a division bar, and then the e guy. Okay, so I got to write all of that out. So let's do that. So I will start off by writing the ln. The first thing I come across is x to the 8th. Okay, ln of x to the 8th, no problem, check. Multiplication symbol means I turn it into a
Addition.
addition. Okay, check. Next, I come across p to the 9/2. No big deal. We'll fix, actually, you know what? Let's fix them right now. Nah, let's not. Let's just write it all out so we can get rid of this big thing. So we have ln of p to the 9/2. Okay, check. Next thing we come across is this multiplication dot, which means I turn it into addition. And then I see q to the 3/2. So the ln of q to the 3/2. Okay, so check. Then I come across the division bar, turn into subtraction, and then I have e to the 8th. So the ln of e to the 8th. All right, so this big old guy up top, completely and totally taken care of. We're not looking back. And so now we're going to go through this little, these 4 pieces that we have written out, and we're going to simplify anything that we can. So this first piece, the ln of x to the 8th, what has to happen here?
The 8 needs to come to the front.
So I will have 8 ln of x. Perfect. Okay, next, so plus sign. Okay, what has to happen with these guys?
The 9/2 comes out first.
Perfect. So 9/2 ln of p. Okay, check. Plus sign. You said 3/2 ln of q. Okay, now think back to yesterday. Generally speaking, we're taking a pause here. If we have the ln of something, isn't that really log base e?
Yeah.
Yeah.
Yeah. And so if we have the ln, if we have the ln of e to the 8th, what that is really saying log base e of e to the 8th. Now, just like 5 minutes ago, we had the same type of a problem, but each of these little guys were a 10. Remember that?
So it would just be 8.
It would just be 8. Because if we say, remember, we're going to say this is equal to something. We don't know what. So that would be e to the y equals e to the 8th. Oh, hey, look, it's just going to be an 8. So this whole entire thing is just the number 8. And this is my final answer. Now it's big, okay, but I followed all of the rules. There's nothing else I can do. If I knew what x, p, and q were, I could type them in and I could come up with a solution. But I'm finished. All right, now what are your thoughts? We've done 10 of them. What do you think?
Not bad.
Not bad. Okay. And so here's what we're going to do then. We're going to go in the exact opposite direction, and we're going to be given a problem that looks maybe something like this, and our end goal is going to be something like this. Okay, so we're going to go in the other direction, and we're going to do what's called condensing. All right? So let's take a look at what that looks like. So now we're going to condense. And when I say condense, we're going to take many logs, however many they give us, and our final answer can only be one log. We can only have the word log one time in our problem. So let's see what that looks like. So I don't know what I'm doing here. 11. So what if we have log base 3 of 5 plus log base 3 of x? And so we start out with many logs, and we need one log. And so we're going to look at this, and between the logs, we're going to say, hey, what's going on right here?
Addition.
And so since it's addition, I'm going to have to condense it and turn it into
Multiplication.
multiplication. And the things that are going to be multiplied is this number and this number, so to speak. And this word log base is going to stay the same. And so what's going to happen is this will become, whoops, I don't want to write in purple. This is going to become log, the base is still 3, and I'm taking this number and I'm taking this number and I'm saying 5 times x. And that's it.
You're just reversing it.
Exactly. And so if you could, for just a second, pretend like you don't even see this, and you start out with this, you would say, oh, look, there's a multiplication, so I'm going to turn it into addition. And so that'll be log base 3 of 5, log base 3 of 5, plus log base, oh, hey, look, yeah. So yes, Sarah, we're exactly doing what you said. We're literally just reversing it. And all of the rules that I applied when we went forward also apply to it while we come backward. That was pretty cool, huh?
Mm-hmm.
All right, let's look at this one. So log base 3 of x plus 2 log base 3 of y plus log base 3. Oh, I can't read my own writing. Can you believe it? That's a number 2. Okay, so there's our problem. Log base 3 of x plus 2 log base 3 of y plus 2 log base 3 of 2. So as we read this thing from left to right, the first thing that we're going to come across is this. And then, hey, we don't typically see numbers out here. Where'd that number come from?
From the y.
Yeah, so it has to come back here. And then we see another plus sign, and then this guy looks pretty okay. And so when we see these plus signs, I know that plus sign means I have to turn it into what?
Multiplication.
Multiplication. And remember, I'm only allowed to have one log in my answer. So I'm going to start out by writing my one log, which is log base 3. What's going to be multiplied here?
X and y squared.
Perfect.
And 2.
Perfect. So this is going to become log base 3 of 2xy squared. Ta-da! And the stuff that you put in parentheses here, typically we just put it numerical order and then ABC order, but it really doesn't matter because it's just being multiplied. So instead of me writing
So we
x,
could have put x to y square.
I mean, we could have. That would look kind of funny, but yeah, you could have. And then that's it. We're done with 12.
You have to put this stuff in parentheses.
Honestly, I do, just to make it very clear as to what's actually being multiplied. I can't recall, just being blunt or being honest, I can't recall if there's parentheses and hawks, because when you're just filling in the box, you don't technically have to have those parentheses. But if you're writing it on paper, I say please put it in parentheses for me.
And then you can always check yourself for what the original problem was.
Exactly. You can always start and say, okay, well, this is what I got. If I split it up, is this what I come up with? Okay, so yeah, you absolutely can. All right, what do we think?
These are easy.
Ooh, I love it. Okay, so how about this one? Log base 2 of x minus log base 2 of y. So because I have a subtraction sign, what am I going to turn this into?
Division.
And what's going to go on top?
X.
What's going to go on bottom?
Y.
Okay, so I'm going to have log base 2 of x divided by y. Ta-da! You guys are killing it. Okay,
Can we condense ln problems or just logs?
sure. Let's condense an ln problem. Okay, so let's do, all right, 14. So what if we had the ln of 2x minus 6 ln, wait, hold on. I gotta start over. Silly me, wrote the wrong thing. The ln of x minus 6 ln of y, let's just say. Okay, and so the first thing that we come across is a subtraction sign, right? And so subtraction means I have to turn it into what?
Division.
Okay, and so the next thing I come across, hey, look, I don't typically have a number in front. So where did that number come from?
Your y.
Uh-huh. And so this is going to turn into ln. Here's my division. What is going on top? What did I come across first?
X
And then what's going to go on bottom? Y to the
6.
6.
perfect. And so regardless of whether I have log or the word ln, the rules work the same. Okay, the
It's the
whole
same
idea,
thing.
it's a good thing, right? Is that what you said?
It's the same thing.
The same thing, yeah. Okay, so let's see. I mean, how do we feel? Do we feel pretty good? Do we need a couple more? Your ideas.
Is there going to be as complex one as like where we were getting to examples when we were on example like 9 and 10
Let's see.
where we have to condense back?
Let's do. Okay, let's do one more. This will be like, I know that this set, we just were on 14, but now we're scooching down to 17 because
I know
this
how to
is
word
more-
better what I was trying to say.
Yeah, no, I got you. You want to know if it's going to be any more complicated. So, sorta. Okay, so watch. So what if we have log base b of 5 plus 2 log base b of x to the negative 1? Okay, because we haven't really seen negatives too awful much. And so the first thing that we do, okay, and again, we're trying to go from 2 to 1, all right? And so we're reading from left to right, and we come across this plus, which means what?
Multiplication.
Multiplication.
Okay, and then we come across this 2.
Goes
Where
with the
the,
B.
okay. Oh, hey, look, this x is already being raised to the negative 1. What's going to happen when I bring this 2 up and I have it beside this negative 1?
Times it.
Yeah, and so let me rewrite this because I'm getting messy here. So this is going to be log base b of 5 plus, and then the 2's going up, so we'll have log, oh my gosh, base b of x to the negative 2. Okay, and so now someone already told me that this was multiplication, which is right. However, okay, we got to pause for a second. Let's write that out so you can see it. Log base b of 5x to the negative 2. So we took care of our multiplication, but here's the thing. We know from way back that we are not allowed to have negative exponents in our answers, ever, no matter what type of math we're doing. And so because of that, it's the only thing that's being raised up is that x. The 5 is not being raised, okay? And so what we're going to have to do is get rid of it, so to speak. So we're going to have our log base b. The 5 is totally fine as it is. What's going to have to happen to this x to the negative 2? Where does it have to go so that it becomes
In
positive?
front.
To the
Bottom.
bottom,
The
maybe?
bottom, yeah, okay? And then when we put it on the bottom, the negative turns into a positive. That's the whole idea. And so now, even though you verbally told me it was going to be a multiplication problem, because it totally was, but because we had this negative 2 exponent, it turns into a division problem. So this is my final answer. So I don't want to say that, excuse me, that's any harder. It's just sometimes there are little ticks that you don't quite think of until you see them. And so this is one of those little ticks that are going to try to get you. Like, Hawks isn't going to let you type it in like this. They're going to say, oh, this is unsimplified answer. And this is why. And so it has to go on the bottom. It has to become positive, and then you will be done. All right. So I think for now, anyway, I think that's probably good as far as our expanding and our condensing goes. Because as always, you guys got to practice some. Okay. So let's look at the next topic. And this topic is going to be so easy that you're honestly and truly not going to believe it. All right. This next topic is called the change of base formula. And there's literally no notes that go, oh my gosh, there's literally no notes that go with this. It's literally just a formula. And then you plug it in. So here's what the change of base formula says. It says log base b of x equals log x over log b. Or, okay, there's a big fat or in the middle. It says log base b of x equals the ln of x over the ln of b. And then here's a super duper important star. It does not matter which you choose. Okay? It doesn't matter which one you choose. Now, here's the idea behind the change of base. There will be some times when I ask you to calculate something. Okay, now don't write this, just watch. Okay? What if I ask you to find log, let's say base 8 of 26? I don't know. And I say, hey, I need you to calculate this right now. And you're thinking to yourself, okay, well, you put your little y over here, you draw your little arrows, you get 8 to the y equals 26. And you think to yourself, well, shoot, there's no number that I can raise 8 to, like, a nice, neat number that's going to give me 26. And so when that happens, there has to be another way. And so we're going to say, you know what? It's not happening. It's not happening this way. I got to do something else. So what's going to happen is we have this thing called change of base. So if these two numbers don't work out, then what we're going to do is we're going to actually take them and make this log base 10, because that's what your calculator is set up to be, of the x value on top, whatever that happens to be, and then we're going to divide it by that log base 10 of whatever that b value is. That's it. And it's all going to be done on the calculator. Now, for some reason, if you're like me, I don't know why, but I have like a love affair with the ln. I love it. I use it all the time. Okay, log's fine, but I really like the ln. And so if for whatever reason you feel like writing ln instead of log, it's the same thing. So let's take a look at an example. And you guys have your calculators out and you're going to do this. So if the question is log base 7 of 15, and I say to you, okay, I need you to solve this. Well, you're going to say to yourself real quick, you're going to say, 7's not going to just magically become 15, because 7 to the first is 7, 7 to the 2 is 49. It's not going to happen. So you're going to decide, do you want to type in log or do you want to type in ln? I don't care at all. Someone tell me. Log, log. Okay, so when we first started talking about the log stuff, we know that this is my base, because we literally say log base of, and this is my x. And so what's going to happen is this is going to turn into the log of 15 over the log of 7. Now, get your calculators out, and here's what you're going to type. You're going to hit log, and then a parenthesis probably comes up. You're going to hit 15. I need you to close that parenthesis. And really the best way is to hit enter now. You're going to get some horrible looking decimal, whatever. Then you're going to hit divide. Then you're going to hit log again. A parenthesis pops up. You hit 7. You hit enter again. And then the answer that you should get, to make sure that you're getting it, is approximately 1.392. So take a sec. Make sure you can get that number, because this is it. Okay? This is it.
Got it.
Got it.
Got it. Okay, perfect.
I put it all in one step.
And that's fine. Okay?
Okay.
That's totally fine. If that's what you're doing, you got to make sure that you close these parentheses. Okay?
Right.
So what this means is, if you could take the number 7 and raise it to approximately the 1.392, that would give you 15. But there's no other mathematical way for us to find this weird little decimal without using this change of base formula. That's it.
Can you do it as ln? I want to see why you like it so much.
Okay, so let me just clarify that. The reason that I like the ln so much has absolutely nothing to do with this particular change of base formula, but we will absolutely do one. I like the ln because, first of all, I like to write that cursive L, but also when we come to Monday and we start doing some actual, like, I don't want to say application problems because that's what we're going to do today, but when we start doing some solving problems, we're going to use this little guy, excuse me, in correspondence with some of the banking problems that we already did. And so in my mind, the ln is more practical. That's it. That's literally it. Okay, but yeah, I'm going to do a couple more of these just to make sure, and we'll pick ln on one to show. Okay. All right, so have you written down the change of base? Because I'm on a new screen.
Yeah.
Okay, so here we go. 19? I think so. Okay, so, and actually, you know what? Let me just write them both down, and I'll give you a minute, and let's see what you come up with. So if we have log base 1/2 of 3, and then the last one will be log base pi. Remember, pi, don't let it scare you, of 5. Now, Sophie, you said the ln. If you want to choose the ln, just write the ln of blah, blah, blah over the ln of blah, blah, blah. When we go to use the change of base problems, this log is always going to be log. We're not going to have ln because we can't have the ln base of 1/2. That doesn't make any sense because the ln is technically log base e. So if you want to see the ln in your problem, you are going to have to choose to do that. Okay? So I'll write down the answers that you should get just to make sure you get them, and then we'll move on because we're almost done. The first one should be negative 1.58. And this next one should be 1.406. Now, somewhere on your calculator is a pi button. Okay, I'm not sure where because everyone's is different, but there is one on there. So take a minute, type these things in, write them out, see what you get. If you're getting them, perfect. If you're not getting them, we got to, probably it's a calculator issue.
I got them.
You did get them. Okay. So then just hang out for a sec. Ooh, got it. Okay, fantastic. And so again, also, okay, so just because if you got it, do me a favor. Whichever one you used, if you used ln or log, use the other one and just prove to yourself while we're waiting for a few minutes that it doesn't matter. Okay, when we use change of basic formula, perfect. Okay, like my guess is that it's probably a calculator issue. So are you on number 19?
Yeah.
Okay, so type in what I say, okay? So let's just use the ln. You're gonna type in the ln, a parenthesis is gonna pop up, you're gonna hit 3. Make sure you close that parenthesis, okay? Then hit enter for me. It's gonna give you a decimal of some sort, I don't care. Division bar, the ln button again, 1 divided by 2, close parenthesis, enter again. And let's try that. Okay, anybody else, chime in. Are you getting it? Are we not getting it? I gave you 2 answers. You could do it with ln or you could do it with log. Doesn't matter.
I used both of them and I got it.
Perfect.
Yeah.
Okay. Okay, so that's it, guys. That's change of base. That's probably the easiest thing in this whole entire section.
Is it going to get any more complex than that?
Not when it comes to change of base, no.
Okay.
Okay, so the reason that I gave you these 2 particular examples that you're looking at right now is so that you could see how to do it if there's a fraction, because I know everyone freaks out about fractions, or how to do it if it's a different constant rather than just a number. Okay, so 18, 19, and 20, just change the base problems, easy peasy, right? No big deal. All right, Lakin, did you get that? I didn't hear back from you.
Yeah, I put in the wrong numbers, so I was getting the wrong.
That'll do it. Okay, so next, so those are our properties of logs, okay? We add, subtract, multiply, divide them, and we use our change of base to manipulate the numbers that we want. Now, the next thing that we have to do, and you're like, oh God, more, but there's only 3 problems, okay? And it's literally, I'm going to be giving you a formula, and you're gonna be plugging it in, okay? I'm teaching you how to use these things in real life, all right? So some of the application problems that we're gonna look at, so here's our applications. And like I said, there's only 3, okay? And the first one is the pH scale. Okay, any chemists in here?
Heck no.
Heck no.
I mean, I've used it like in high school for
Of
science
course,
class,
yeah.
but I haven't used it since.
Okay, well, remember what I said the other day. We're in a math class, right? And so do I care about the pH scale? No, not really. What I care about is the formula that I give you. Can you type it into your calculator and make sense of the answer? So here's the formula. And again, you're going to have these for your exam. So the pH formula is negative log, and then there's a bracket, or brace, I suppose, and then H3O plus. Now, do I know what H3O plus means? No. But do I know that when I give you a problem, I'm going to give you this in terms of numbers? Yeah. Okay. So don't let the fact that there's that weird chemistry symbol scare you. Doesn't matter. Now, here's the example. So we're going to use this formula to solve this problem. Okay. Orange juice has the H3O plus, whatever that means, okay, of, hey, look, here's the number. Remember, we're mathematicians right now. 1.58 times 10 to the negative 4, okay? Period. Question mark. Or no, the question, what is the pH of orange juice? All right, well, what's going to have to happen is, in the problem.
Does that say OT?
This says OJ, orange juice.
Well, in the brackets.
Oh, I'm sorry. No, this is a 0. This is just a little plus sign above it.
Oh, okay.
This is a chemistry thing. I don't really know what it means. All I care about is that I know this is actually equal to that.
Is that an X or a times?
Okay, hold on. I'm getting excited because I like this stuff. I'm out of control. Where at?
The 1.58.
Yeah, this is times. Sorry. Times. Okay. 1.58 times 10 to the negative 4.
Is it okay if we put it in parentheses instead?
Sure, that's fine. Okay, so here's the question, all right? Given this information, what's the pH of orange juice? Well, according to my formula, the pH of whatever is negative log of this value. Do I have this value written out as numbers? Yeah, it's right here. And so what I'm going to do is I'm going to write my formula. I'm going to say, okay, well, the pH equals, I'll write a little bit slower, a little bit neater, the negative log. Now, instead of me putting brackets and writing this H3O plus junk, I'll just put my little bracket and I'll put the value. So 1.58 times 10 to the negative 4. And then guess what I get to do with that?
In your calculator.
Exactly. Okay, so I'm going to type negative sign. Make sure you use the LOG. A parenthesis will already populate itself. You'll type in 1.58 times 10. You'll raise the 10 to the negative 4. Jump down out of that. Close it off with the parenthesis. Hit enter. When you do this in Hawks or on the worksheet or whatever, it's going to say round off to the nearest whatever. This one's just one decimal place. So the answer for this one is 3.8. So make sure that you can get 3.8.
I got it.
Okay, then just
Got
sit
it.
tight for a sec. Okay, because
I got
that's it.
negative 2.79.
Okay, so my guess is it's a calculator issue. Okay, so one thing that I want to have you guys pay really close attention to is whenever you type in this negative sign on the log, make sure that you're not hitting a subtraction sign. There's a difference on your calculator between the negative sign and the subtraction sign. So Sydney, that was you. Try it again for me.
Okay.
Okay. I'm really glad that we all met before this class, went online so that I can recognize your voices. Okay. Anybody else?
I got it.
All right. Those of you who are just typing into me, let's see. Molly, Lakin, Logan, Lucas. Any issues with that? Anybody have anything? That's pretty straightforward.
I
right?
got it.
Okay, great.
I'm having trouble. Can you tell me how to put it in one more time?
Sure. So clear your calculator out totally. Okay.
Mhm.
This is the first thing that you have to type, but make sure you hit the negative sign, not the
Mhm.
subtraction sign.
Mhm.
Okay. And then you just hit the log button. The parentheses should already pop up. Does
Yeah.
it? Okay.
Yeah.
So 1.58. And then your multiplication sign.
Mhm.
And then the number 10. And then probably your caret button.
Mhm.
And then your negative 4. And then you're going to have to use your arrow, your right arrow, to come out of that where that exponent is.
Oh.
And then hit a parenthesis to just close it off. And then hit enter. And you should be good to go.
Okay, got it. Thank you.
Got it? Awesome. Okay, so there's pH. All right. And again, the only thing that we mathematicians are concerned about really is this number and this formula, which again, I'll give you the formula. If you looked at the formula sheet, it's already there. Okay, so this was pH scale. Ready for the next one?
Yeah.
Okay, so the next one, so this is going to be the Richter scale. Does anybody know what that is?
Oh, it measures how strong earthquakes are.
Absolutely. Okay, so we're going to be talking just very briefly. And again, we're
How
not,
you guys just know that.
well, some people just know things. I don't know. Okay, so the Richter scale is what is used to measure an earthquake. Okay, and they typically, it's usually a whole number and then a decimal point and then something else. So it's usually like 2.6 or something like that. Okay, and so the Richter scale, the formula is this: R for Richter equals log, and then in parentheses we have a capital I on top. And we have an I sub 0 on the bottom, and it's a division problem. Okay, and that's the formula. And so let's say here's the problem. So example number 22. So we're going to say that an earthquake was 80 million times, and I don't mean multiplication, I mean like 4 times as much money or something like that. So 80 million times as intense as a level 0. Question mark, or the question is, what's the Richter? And again, remember, we're mathematicians, okay? So we don't want to get caught up in all these words, all right? What we're looking for is numbers, all right? And so we know we have this formula right here. And so, oh, hey, look, here's a number. And what's going to happen is this I value is going to be the intensity, okay? And this intensity right here, this I sub 0, this is just the initial intensity. Now, this is a little deceiving because it says level 0, and we very well know that we can't divide by 0. So wink, wink, most of the time when we have a problem like this initial intensity is not going to really affect us because the initial intensity is not 0, okay, because we can't divide by 0. So all we're going to do in this problem is literally take this number and put it right here. And so we're going to have R equals log, parenthesis, 80 million. And then guess what we're going to do, whoops, with this number?
Calculator.
Okay, so see if you can get that. So it's literally just the log button, 8 with a ton of zeros, and enter. And here's what you should get, 7.9.
Yep.
Okay, got it. So just sit tight for a sec. That's it. And again, when we see the Richter scale, it's going to mainly just be one number, and we're not going to have to worry about that I sub 0. All right, any problems with this one?
No?
No.
All right, someone type it in. Okay. All right, so that's the Richter scale. Okay, easy, no big deal at all. All right, so the last one then, okay, and this will be the last problem unless you guys are just dying to do more.
Wait, I
Um,
have a question.
Oh, yeah, let me go back. Okay, go ahead.
So that was level 0. Are we ever gonna have one that's not 0?
Yup, that's what we're about to see next, okay?
Oh, okay.
All right, so the last one that we're going to look at today is the decibel scale. What's that?
Isn't that like sound or?
Yes. Okay,
Yeah.
that's exactly what it is. The decibel scale.
Amazed.
The decibel scale measures sound. Okay, so here's the formula: D for decibel, the number 10, the word log, and then that I business. A regular I on top, I sub 0 on bottom. That's the formula. Here's the problem. Given, okay, and it's going to literally say given to you, I sub 0 is 10 to the negative 12. Okay, then it's going to go on to say, what is the decibel? Whoops, spelled it wrong. Shoot. DEC. You guys know me enough to know that I am not the best speller, and I'm okay with that. There we go. What is the decibel if the sound intensity is 50? Okay. All right, so we're given this brand new formula, D equals 10 log of I over I sub 0. And then in the problem, they literally come right out and say, hey, look, I sub 0 is 10 to the negative 12. And then it goes on to say, oh, hey, look, the intensity is 50. That's all I care about. And so now I have my numbers. And so I'm literally going to just write, okay, well, D equals, I'll have my 10 log. And then on top, I have my intensity of 50. And then on bottom, I have my I sub 0 of 10 to the negative 12. And then guess what I'm going to do with that?
Calculator.
Calculator. And also in the instructions, it's going to say round to the nearest whole number. So I want you to practice typing it in and make sure it's going to be 136 point something, but we're rounding it up. So type this in, try it. If you get it, great. If you don't get it, tell me, what happened. We'll look at it and then we're done. I'm done.
Got it.
Got it.
Okay, then you're good. Anybody not getting it? That's really my main concern, is if you're not getting it. Because again, as you guys have already seen in this section, we are very, very heavily reliant on our calculators. So we have to make, oh, a smiley face. Okay, we have to make sure that we can get this. All right, so before I turn off the whiteboard, that's it as far as these sections go. So we talked about the 3 properties of logs. Hold on, let me get this whiteboard off real quick so you can see me. I know that you guys miss my face so much. Okay, so we talked about the 3 properties of logs. We talked about expanding the logs, going from 1 to many. And then we talked about condensing the logs, going from many to 1. Okay, well, Sparky's in here. He might come say hi. And then we talked about the change of base formula and how easy that is, about how we just type it right into our calculator. And then we have the pH scale, and we have the Richter scale, and we have the decibel scale. And again, the formulas that you need, you will be given. It's just a matter of choosing the right one and typing it into your calculator correctly. So what are your thoughts? Here, Spark, come say hi. Anybody have any issues with that? He's
No, it's not really bad.
It's not bad, right? You guys were all terrified and scared. Some of you guys, oh, I hate logs. Why? Okay, keep in mind that the 7172 assignment's due tonight, correct? Yeah. And several of you have turned that into me here. As soon as we get done with class and I upload the video, I'm going to go ahead and start grading those and getting them back out to you. And several of you have sent me those video consent forms. Thank you. I have I've said thank you, and I've sent out the scores. And I think that's it. Unless you have any questions or problems with me, then I'm good. Anybody have anything they need to talk to me about? Stay behind. Otherwise,
So we have the worksheet due tonight and Hawk 7.2.
Yeah.
Okay.
Yep. And then, so now you've covered 7.3 and 7.4. So you have the weekend really to work on the Hawks and the worksheet. And when we come back Monday, we'll finish the chapter, and that'll be the last section of new stuff that you ever have to learn from me. Okay. And then we'll practice for a couple of days, and then we'll take the test, and then it'll be time for the final when it rolls around. So anything else right now?
Do we not have 7.5 in Hawks?
We should. Is it not showing up?
No, when I looked, I only had 7.4.
Okay. Thank you. I'll have to go check. Because I already did that section.
I have Hawks 7.5 due the 22nd.
That should be right. Sydney, will you do me a favor and just check again?
Yeah.
Because it should be there. I'm not saying it's not. It is, but it should be there. So just check later and let me know. Okay.
Okay.
All right. Anything else, guys? If not, I'm peacing out.
Oh, Amanda,
Yeah.
I wasn't able to come to class on Wednesday, and I was looking at your notes, and they're not loading. Like on Blackboard,
Oh.
it says not found.
Has anybody else happened to have tried that either?
Not with those ones. I tried the other day for something, and they loaded. Eventually, I
Okay.
had to like download them.
Okay, hold on a second, Molly. Let me make myself a note, and then I can just send them to you directly. But that should not be. So Molly, it was yesterday, right? So 7.3 notes. All right, I will scan those right over to you. I don't know why that's not loading, but can I send it to you through Remind? Would that be okay?
Yeah, that will work for yeah.
And then Sydney, I need to look at 7.5 Hawks. Okay. All right. Any other issues that we're having? Okay.
No, I'm good.
Okay, Molly, I'll send those to you in about 10 minutes or less. Depends on how long it takes me to get them scanned in. And that should be it. Okay.
Okay, thank you.
All right. You're welcome. Okay, guys. I'm gonna go ahead and sign myself out so I can get some of this work done. Unless you need me, then we're good to go.